Here's example 6 with using sum and difference formulas for evaluating trig expressions. So here we have the tangent of 15 degrees, we want to evaluate that. So the idea is to express 15 degrees as a sum or a difference of two special angles on the unit circle, and then use the corresponding formula to evaluate. So we're going to use this formula sheet that we've been using in the previous videos. If you want a copy of this, check the video description. There's a link in there. Click that link and get a copy of this formula sheet here. So evaluate the tangent of 15 degrees. So first we want to express 15 degrees as a sum or difference of two special angles. So 15 degrees is pretty small, so we probably can't express it as a sum of two positive angles anyway, positive special angles. So we can express it as a difference. So let's say, so we actually had 15 degrees when we did example 2 with cosine of 15 degrees, and I think there we did 60 degrees minus 45 degrees. So here let's do 45 degrees minus 30 degrees. Okay, so but you know, we could do 60 degrees minus 45 degrees again. It will totally work just fine, because these are all special angles on the unit circle. 30 degrees, 45 degrees, 60 degrees, they're special angles on the unit circle. So any combination that works, we can use them. Okay, so anyway, tangent of 15 degrees equals tangent of 45 degrees minus 30 degrees. And if we go to our formula sheet, so here what we have is tangent of one angle, so this will be our alpha minus another angle, that's our beta. So tangent of alpha minus beta, okay? So here tangent of alpha minus beta, we see that that's tan alpha minus tan beta, all divided by 1 plus tan alpha tan beta, okay? Okay, so this is going to be tangent of 45 degrees minus tangent of 30 degrees, all divided by 1 plus tangent of 45 degrees times tangent of 30 degrees. Okay, now it's just a matter of knowing the unit circle. So tangent of 45 degrees, that's 1. And then tangent of 30 degrees, that's the square roots of 3 divided by 3. And then 1 plus tangent of 45 degrees is 1. And then tangent of 30 degrees is root 3 divided by 3. Okay? Okay, so we come up here. So 1 minus root 3 over 3, 1 plus root 3 over 3. So this equals 1 minus root 3 over 3, and then 1 plus root 3 over 3. Now we actually had an expression similar to this in the previous video when we did example 5, and what we did was multiply by 3 over 3. So the other way to do that is to get a common denominator. So since we did, since in the previous video we multiplied by 3 over 3, which will totally work, it's totally fine. Since we did that in the previous video, let's do it the different way in this video. So the other way is pretty much kind of the same thing behind the scenes, but what we want to do now is with these 1s, so I guess we can actually leave them where they are. We'll take the 1s and multiply, we'll get a common denominator basically. So we'll get a common denominator separately in the top and the bottom. So up here on the top we have 1 minus root 3 over 3. So what we want to do is take that 1 and multiply it by 3 over 3. So multiply that by 3 over 3. And then same thing here with this 1. So multiply this 1 by 3 over 3. Okay. So then what we have is this equals 3 over 3 minus root 3 over 3, all divided by 3 over 3 plus root 3 over 3. Okay, so now that we have those common denominators, we can say, okay, this equals 3 minus root 3, all divided by 3. Okay, and then that's divided by 3 plus root 3, all divided by 3. Okay, so this thing on top divided by that thing on bottom. Now when you divide by a fraction, it's like multiplying by the reciprocal. So then this equals, so this whole thing on top, 3 minus root 3 over 3 times the reciprocal of the bottom. So that's going to be 3 over 3 plus root 3. Okay. 3's cancel. Okay, and we end up with 3 minus root 3 all over 3 plus root 3. Okay. Now again, just like in the previous video, what we want to do at this point is rationalize the denominator. Okay. So if we rationalize the denominator, what's nice is that in this case it's probably going to give us something quite a bit more simplified than what this is. So rationalize the denominator, multiply the top and the bottom by 3 minus root 3. 3 minus root 3. Okay, and we're pretty much actually out of room over here. So do kind of hate to erase any of this, but it doesn't really matter. So let's erase this. We'll just come up here now. So now this equals. So what we want to do is FOIL. So if we FOIL on the top, first gives us 3 times 3, which is 9. So that's going to give us 9. And then outer, 3 times negative square root of 3. So outer is going to give us minus square root of 3. Or sorry, minus 3 times square root of 3. So minus square root of 3 times 3. Okay, so we have minus 3 root 3 for outer. What about inner? Inner gives us minus root 3 times 3. So it's going to be another negative 3 root 3. So minus 3 root 3 again. And then how about last? Last is negative root 3 times negative root 3. So two negatives multiplied together give us a positive. Root 3 times root 3, the square root goes away and we just end up with 3. Okay, so that's going to be plus 3. Okay. What happens on the bottom? On the bottom, the square root is going to be, it's going to go away, which is the whole point of doing this rationalize the denominator. Okay, so we take an irrational denominator and make it rational. That's why it's called rationalizing the denominator. So 3 plus root 3 times 3 minus root 3. FOIL it, then first gives us 3 times 3, which is 9. Outer is minus 3 root 3. Okay, minus sign and 3 root 3. Minus 3 root 3. Inner is going to be plus 3 root 3. Okay, plus sign and then 3 root 3. Then we see that we do have a cancellation here, which is nice. It's exactly what we're looking for. And then last is plus root 3 times negative root 3. So we have a minus sign, and then square root of 3 times square root of 3 is just plain old 3. So then minus 3. Okay? So then when we simplify everything, we end up with, on the top, 9, blah, 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 plus 3 is 12. Minus 3 root 3, minus 3 root 3, so that's going to be minus 6 root 3. Okay, so remember, we can combine them like that because it's the square root of 3. Okay, if this were square root of 3 and this was square root of something else, we could not combine them at all. Okay, but since it's square root of 3, we can combine them like this. Okay, so that takes care of the top, and then on the bottom, what happens? 9, blah, 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 minus 3 is 6. And notice negative 3 root 3 plus 3 root 3, that's great. These cancel. It's exactly what we're looking for. It's exactly what we wanted. So we're trying to rationalize the denominator. Okay, so now 12 minus 6 root 3 all over 6. So we can simplify. We can pull out the common factor of 6 on the top. So we have 6 times the quantity. Okay, let's maybe switch to a different color. We have 6 times the quantity. If we pull out a 6 from the 12, we have 2 left over. If we pull out a 6 from here, we have a root 3 left over. And then down here is still just 6, so this 6 cancels with that 6 that's down there. And then what we end up with is 2 minus the square root of 3, which is totally more simplified than 3 minus root 3 over 3 plus root 3. Okay. And if you are required to rationalize the denominator, you'll have to go this route anyway. So anyway, that's example 6 of using sum and difference formulas to evaluate the trig expression. Here we had tangent of 15 degrees, and here's our answer once again, 2 minus the square root of 3.